All right, so when we start doing these, step 1 is to, 1, decide which function it is. Okay, so that's the first thing we have to do. So step 1, decide which function it is. All right, and number 1, what is the V? What's
absolute value.
That is absolute value. Okay, so now we have decided which function we think it is. It is absolute value. All right, I agree with you. That is absolute value. So step 2 is to write the equation for that function.
I didn't know you spelled
Okay, so 2, we want to write the equation. All right, so to write the equation, we have to do a couple things. 1, we have to think about where did that translation point go? Where did it go? All right, so this one went -1, -2. So my translation point on this one is -1, -2. Could you have seen that if I didn't highlight it?
Yes.
Could you have figured that one out?
Yes.
Okay.
So the equation would be
Okay.
absolute value x plus 1,
X plus 1, I love it.
and then minus 2.
And then -2. So once we figure out the translation point, it makes writing the equation a lot bigger, a lot easier. All right, gentlemen, the last thing you want to do on the equation is decide, is this normal moves or did I multiply the y's by anything? This is normal because the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3. So we don't need anything out in front. We're not doubling them, we're not tripling them, we're not halving them. None of that is happening. So my equation is good. Now, if this were a normal absolute value function, it would keep going this way and it would keep going that way. But it doesn't, okay? This one has a starting and a stopping point. So step 3 is to write your restriction on the domain. Now those are big math words, but it's not a hard process. So let me show you how this goes. So step 3 for us is the restriction on the domain. Now, because this one has a start, and a stop, we can write it 2 ways. I'll show you. It starts right here at that x value, and it stops right there at that x value. Do you see it starts right here? Because we always go left to right. You always go left to right. This has a start and a stop. Okay? What is the x value where it starts? What is the x value right here, guys?
6,
1,
-6.
2, 3, 4, 5, 6. -6. Okay.
You put a bracket.
We're gonna write it 2 ways. Yep. The bracket, and where does it stop? At 2. So this is what it looks like as an inequality, and your teachers are gonna accept the the interval. They're gonna accept the interval. The other way we could write this is as an inequality. Remember, when it comes together like this, it's the least value less than or equal to x less than or equal to the greatest value. Now, interval is what you use when you go to higher and higher and higher level math. Inequality, though, is what we're going to see on the ACT and the SAT, because that kind of stops at Algebra 2. Those 2 tests don't cover much more than Algebra 2. So when you take those tests, this will be what your answer looks like. When you take, if you choose to go to college and you take college algebra, this is what your answer is going to look like. They mean the same thing. They mean the exact same thing. All right, so we're going to do this on every single one of these until we get this process down. Step 1, identify your function. Decide which function this is.
Cubic.
It is cubed, but it is a cubed
Oh,
root. Okay? Now remember, the cubed root goes sideways, left and right, versus the cubic goes up and down. So this is a cubed root, because do you see it going sideways? Okay. All right, so that is the first thing we have to do. What is it? Determine which function we're dealing with. All right, now we got to write the equation. So to write the equation, we got to figure out which one of these points is the TP. Which one's the translation point? This one. And how do I know it's that one? Because it's the middle of these two. Yep. So you find the symmetry, and it's the one in the middle. You find where it's symmetric, it's the one in the middle. So that's our translation point. All right, so let's see if you can set up the equation for that. Okay, so this point was +2, +3. The translation point on this one was 2, 3. So I'm going to need an x -2 in here, because remember we always do the opposite with the x, and a +3 at the end. Now, this one does need something out in front, because a normal one would go -1, the cube root of -1 is -1. The cube root of positive. So a normal one would have gone this way, right? So what does this one need out in front? It needs a negative. Yeah, this takes a little while to figure out. That's why we have 12 examples today, whereas we usually have like 5. All right. Now we have to do the domain. All right, so we always look at this. We have a start, but it doesn't have a stop, does it?
No.
So it's going forever this way. It's going towards positive infinity. So this one has a start, but not a stop. So it's going to start at what x value?
-6.
-6, and then it goes forever right. Now, if we were to write this as an inequality, it's all the x values that are greater than or equal to -6. My plan is for my students to allow them to write it either way. That's my plan. And I'm going to share that plan with all the other teachers and let them know that I'm going to give all my students a choice. They can write it as an interval or as an inequality, whichever one works best for their brain. Yes, ma'am?
So when it's like the dot, that's when it stops. That dot represents it stopping?
Yeah.
Okay.
Yeah. All right, let's take a look at the next two. Okay, so step one, what is it? This one is a cubic. Okay, so it's going the other direction. So we got to have something cubed. All right, do you see the translation point?
Yes.
Okay, good. All right, so the translation point's right here. Oops, I thought I was changing it to highlighter. Right here. So it's 3, -2. So it's going to be x -3 -2, because we decided the TP was 3, -2, our translation point. All right, now, are those normal moves?
No.
No, what did we do?
Yeah.
We halved them. Very good. You have to have a half out in front. Instead of going 1, 1, we went 1/2. Instead of 2, 8, we went 2, 4. So it's a half out in front. All right, so this one has a start and a stop. A start and a stop. I would recommend that you get you a little highlighter and you highlight, just like I am, so you can see it. Huh?
Do you use the X intercepts?
You always use the X, because if we look back, do you see how I'm writing it with X's? So you always use the X, yes. So when we're really restricting the domain, and domain is our X's. Okay, so where does this one start?
Starts
At 1. And where does it stop?
Ends at 5.
Very good. Okay, so that's how it would be written as an interval. And then as an inequality, it looks like this. From 1 to 5. Yes, ma'am.
How do you know whether it's a cube, like a cubic or a cubed root?
Okay, so cubics go up and down, up and down. So they'll look like that or like that.
Oh,
These are the cubics. Now cubed roots go sideways. So they're going to look like this or like this.
Okay.
All right, now number 4. We didn't study it this year, but you started studying it in like 8th grade. What is that,
A
folks?
linear.
It's a linear function. It's a line. This is a line. So this is a throwback function. And do you guys remember that the one form of a line is y equals mx plus b? Okay, the other form you learned was called point slope, and it's y minus y1 equals m times x minus x1. I would go with y equals mx plus b whenever I can. If you can use that one's the easier one. Okay, so we know that's it, y equals mx plus b. Now, m is your slope, that's your rise over your run, not rum. B is your y-intercept. B is your y-intercept. Okay, so I can count my slope. Here's a point, here's a point. I go down 2, right 3. So rise over run is negative 2 over 3. Negative 2/3. Plus, now I need my y-intercept. Well, that is my y-intercept right there. It's 1, 2, 3, plus 3.
Was this like just having a practice problem, or are we gonna have this on quiz?
You will have it on your quiz, but your quiz in here won't be until next Wednesday, and your quiz in math class won't be until next Friday.
Okay.
So we'll have lots of practice. All right, so our step 3 is the restriction on the domain. So the restriction on the domain, this domain is going to look like this. It's going forever left. Do you see that? What?
Negative
Negative infinity, good.
to 6.
And it stops at 6. Beautiful. So that is how you write it as an interval. As an inequality, it would look like this. All the x values that are less than or equal to 6.
Did you hear her?
She's a little special today.
I heard something.
Well, I look up and you're back, and it's like you're having a rock concert back there. Swinging that hair around, you're kind of
I was trying to get out of my face body.
dancing.
My hair's pretty good.
So, that's all.
You don't probably. Oh my god.
Alright.
I was just thinking that.
No, I don't know.
I feel like it's only people with
Oh, I messed this one up.
So,
look at something like
Oh my
that.
god.
no, last year, she was like, like cost, and it all be like,
Oh, is this supposed to be a square
She used to
root?
never have.
What?
It is a
Actually,
square.
couldn't like.
This is supposed to be a square root. It should go to right here, folks. Does yours go right there? Did I
No,
fix it?
it's just,
Nope. Alright, I messed up. Make this one go all the way to here. I messed up. Make that one a little, make it go over 4. Does it go over 4?
ours was over in grade. Mine goes over in
Alright, dual.
One, two.
Wait, wouldn't it be higher?
No, I messed up.
Are you talking about from the point or from the center?
From the point.
From the vertex.
Oh, I see now.
Yeah.
That's supposed to be
I
over.
messed up. See, I'll change colors. It should go to right here, guys. It should go to right there. I goofed.
Okie dokie.
I put the point in the wrong spot. Sorry about that. Yes, it does. Okay. So, which one do you think this is?
Square root.
It is square root now. Now that we have corrected it, it sure is. So, square root. Okay? So, this is our translation point right here. That's our translation point. So when we go to write this equation, it's square root. It goes right 1 and down 2. So the minus 1 is inside, the minus 2 is outside of the radical. All right, but we got a restricted domain. It's not the whole function. It doesn't keep going. So this one starts at, where does it start? Okay, at 1. And then where does it end? At 5. Now that we corrected it, it ends at 5. Before it was wrong. Okay, so this would go 1 is less than or equal to x is less than or equal to 5.
You did the same
I did. I had the same interval. Yeah.
So good.
It will. It will. That's why we're doing baby steps. Baby steps. Good. Good. All right. Number 6. What is it?
Oh, it's quadratic.
It is. It's a
I
quadratic.
was about to say a square, but no.
It's a square.
It's a quadratic, also known as a parabola. Okay. So, here's my translation point. Down here at the bottom. It's in the center of the symmetry point. Okay? So, let's see if we can write the equation. Quadratic goes like that. Let's see if you guys can do it. All right, check it. Did you get x plus 2 squared minus 4?
Yep.
Yay! All right. Were you able to do the start and the stop? This one has a start and a stop. So this one starts at
Negative
-4
ends at -4.
and it stops at -1. So it would look like that, or we could write it like this. Okay, now I want you to flip over to the back, and what I want you to do first is step 1. I want you to tell me what you think each one of these are. I don't want you to go any further. Just step 1. What do you think they are? That's what we'll do first.
Hey, what's that thing that we learned yesterday with the steps?
Rounding up and rounding down. You can just say round up or round down.
Okay.
cubic. Sideways is cubic.
Round up and round down.
What's that thing?
Round up and round down.
Just say now. Wait, what? I said I forgot what we were learning now.
Oh.
I don't know what my nouns are. I thought you said you didn't know what your nouns were. I said what? Wait, nouns, person, place, image, or object or idea. Like, cat.
What was Miss Burnett?
They're small.
Well, you don't have
I didn't even know that.
Do you remember?
I go to her like.
Oh wow, I just got on my
It's nap time.
I think they should take it with that.
Hey, guys, 2 months until Christmas.
There's actually.
I'm tired of taking that.
I don't want to take it.
Okay, alright. I can tell from the communication we're ready to go. Alright, number 7. Did you decide it was absolute value?
Yes.
Okay. Alright, number 8 is a cubic. It's only part of one, but it's a cubic. Number 9 is also a cubic. Okay, so if they go up and down, they're cubics. If they go sideways, they're cubed roots. Okay, number 10 is a line.
If I said linear, is that okay?
Yeah, if you said linear function, that's fine. This one is a round down. And this one is a round up.
Oh, yes.
Alright. Did you identify them correctly? Alright. So now let's go back.
I thought it was a square root.
But gotcha. A little tricky.
It looked like almost project.
Okay, so now we gotta find the TP. Translation point. Alright? So that's what I want you to do next. Find the TP on everything but the line. Well, the first 3. Find the TP on the first 3. I'll talk to you about how to do step in a second. Because there's a whole bunch of right answers. Alright, so we got a TP right there, we got one right there, we got one right here. So this translation point is 1, 2, 3, 1, 2, 3, 4. So it's 3, 4. Alright, this is absolute value, so it becomes x minus 3 plus 4. But this one opens which way? Down. So we need a negative.
It'll be -2.
And it needs to be 2 because we go down by 2s.
Wait, I didn't know you were.
I didn't. We just talked us through it. Okay? Now, I want you to see if you can do the restriction for the domain. Can you do the restriction for the domain?
The domain.
You can chill it.
So everything was greater than 1.
Okay, well, when you think about it, think about like what's
Real Jordan!
This will be
I'm proud of it. It has a personality.
Hey, Miss Wendy. Hey, for the up and down, how do you know where the
It's in the middle. It has to be in the middle of
I've
the.
made myself
So this one,
shaky.
for that one, hold on, no, I'll show you in a minute.
Yeah.
Yeah, we'll get there, we'll get there. Alright, so, this one starts right here and goes forever right. So it goes from 1 to infinity. That's what it looks like as an interval. As an inequality, it would be the x values that are greater than or equal to 1. Do these two make sense to you, that they mean the same thing?
Yes.
I like to do the bracket one.
You like this kind?
Yeah.
Okay.
Because it's like visual and you can like.
It is. I like it too. All right, number 2. This is a cubic, and it's been shifted left 2 and up 1. But it's backwards. Instead of right and up, we went right and down. So what needs to go in front? A negative.
Wait, why'd you square it?
Because I goofed.
Oh.
Thank you. All right, now let's do the restriction. This is where it starts, and it goes forever that way. So it goes from 1 to -3 to infinity, which is x values that are greater than or equal to -3. All right, number 9. This is another cubic, and it's also going the wrong way. This is 1, 2, 3, 4, 5. Is that what you guys got? 5? Okay. So, now, because I'm going over and down, it needs to be negative. But when I go over, I go down 2. So it needs to be -2. All right, now let's do that restriction on the domain. This domain, what does it look like? Now, it goes forever this way and stops right there. So, negative infinity is where it starts because it goes forever left and it stops right here at -4.
So you read like the negative infinity first because like you did left to right.
Exactly. So x is less than or equal to -4 is the inequality that matches that interval. All right, so this is a line. We're going for y equals mx plus b then. The slope is up 1 over 2, up 1 over 2, up 1 over 2. What kind of slope is that? 1/2. And the y-intercept is right here at the origin. So that's it. That's the whole equation. All right, now the restriction on the domain. This one has a start and a stop.
So -4 to 6.
Very good. From -4 to +6. So as an inequality, it would look like this. All the x values are between -4 and 6. Okay, so the last two are different.
I'm sorry.
The last two are rounding functions. So we really can pick any place to start. I think it's easiest to start on the y-axis. So that's where I would always start. You can really pick any of them, but I always start with the solid one on the y-axis. So here's my hint to you. It's easiest if you start with the solid on the y-axis. Pick that step to start with. Okay, so this one is a rounding down, we decided, because down is solid over to open. So I need some kind of symbol that means down. Some kind of symbol. Now, this isn't quite right though, because are these 1 unit in length? No, they're 2. What do I need to do to this x?
X over 2.
Divided by 2. Okay, so this has a start right here, and this is a weird stop right here. This one is starting at what? -4. And it's stopping at 6. But do you see where it stops? It's an open circle, so you nailed it. That's right. We can't use a bracket, we have to use the parenthesis. So with step functions, one end's going to be a bracket and the other end will be a parenthesis. Okay, so how would we write this one as an inequality? It would go less than or equal to here, but then just less than here. All right, so I said my hint to you for any step function is find the solid one that's on the y-axis. So I'm going with this one. I always start with the solid one on the y-axis. So we know this is up. I know it's up because the greater barbell is shaded in. This is down because the smaller barbell is shaded in. Okay, so this is up. So I need an up. All right, these are 1, 2, 3 long. So it's x divided by 3. But this solid started up 1, 2, 3, 4, 5. Now, instead of jumping up, we jumped down. And how far did we jump? 2. Yes, sir.
I thought that was, you said it should be opposite of what you're dividing by.
You do. So since these are 3 long, what's the opposite of dividing by 3? Multiplying by 3.
Left and right.
Oh, okay. All right, now we got to do the domain. This one has a start here and a stop here, but what do we notice about the start? Has to be a parenthesis. So it goes from -3 to +6, and what about the 6? Bracket. So the inequality would look like this. It kind of is. Instead of graphing, we're writing the equation and the restriction. Yep. Okay. So today was a good day. Today was a good day. You guys did a great job figuring out which function it was. I think the tricky part are the cubics. So the cubic, up and down, cube root, sideways. So if it's going sideways, it's got to have the radical with it.